Okay, this beast, this poor old lady. See, I pulled the chassis out of the cabinet, and we're looking at the underside of it here. Of course, these hang upside down. Still out here in the garage. I apologize again for the noises. I'll try to keep that in mind and talk over it or just wait. It's May 1st, 2016. May 1st. South Central Pennsylvania. It's 50 degrees Fahrenheit. About 3 p.m. Oh boy, howdy, I wish spring would get here. Anyway, enough of that rant. So what am I seeing up here? Nothing horrible. I do see some things that might be unfortunate. I'll point out this power transformer. I'm sorry for the tapping. This power transformer, at least from the underside, looks okay. I mean, a little bit of rust on it. Solidly secured, moored. Choke coil is loose. That does not surprise me. Those are probably self-tapping screws that just tighten those down. Assuming this is still functional, it probably is. The output transformer, of course, matching the plates to the voice coils. And interesting, the way they thread these through, you can see them, and the leads themselves appear to me at this point to be in good shape. That would be the 2 ohm output for the speakers, to the speakers, and then the center tap primary coming from connecting to the plates of the output tubes. Some rust on this. Not horrible. The laminations aren't. Who cares about these end bells, so much? I could be cleaned out off of that. These laminations, they really need to be insulated from one another. Iron oxide is an insulator. What some folks get into trouble with is they see that rust and they react with horror and they start cleaning it. Don't do that, because if you do that, you're going to cause the laminations to electrically connect to one another. That's not good. Don't do it. Just if it's got rust on it, just let it be. Maybe put some Rust-Oleum on it if you don't like the looks of it, but don't put steel, don't put sandpaper, emery cloth, your little grinding wheels and wire wheels. Don't do it. You'll mess it up real fast. And the same with the power transformer, a little bit less so, but these audio output transformers are they're kind of finicky anyway, given what they have to put up with. I'm hoping that's going to turn out to be okay. So far, it looks like it probably is. I don't see any evidence of burnage. Well, we'll find out. This concerns me a little bit. This transformer, of course, keep in mind this hangs upside down from where you're seeing it. There are 2 blobs of wax on here. They're drips. Often these transformers were potted with beeswax, and that sure does look like what has dripped off of the core of it. This transformer is what couples in this actually drives the reverb tank pan, if you like. That might under normal circumstances, see as much as something like 5 watts into it, through it, to drive the reverb tank. At least the tube that they use to drive this transformer, which is the matching transformer. It matches the tube's output impedance to the impedance of the input to the tank, which is, you know, essentially it's just a coil, like a speaker. But anyway, this, for whatever reason, has gotten warm enough to melt the beeswax in it, and it has run out some. There could be a number of reasons for that. It could be just temperature during normal operation. But we see all these tube sockets here. They're all the same. Notice how this one's dark. It's been baked. I'm not sure. I'll look and we'll find out. But I suspect that tube, the 12AT7, which can put out 5 watts, it's a twin triode, and they have it wired where both triodes are connected in parallel, so it ends up being one big honking triode, which plate dissipation, that thing is 5 watts, normal. The way that's coupled, a certain capacitor under the hood, if it gets terribly leaky, which is likely, it's going to put just DC through the primary of this, and it's going to heat it. Hopefully, we'll keep our fingers crossed, this is not mortally damaged. We will find out. Oh, hopefully. I mean, there are other things. If this output transformer shot, I'm pretty much done with this. Power transformer, we'll see about that. Choke, that's easily replaced. There are a lot of things that could fit that. This can, under there are the some electrolytics for the high voltage power supply. I have not taken that can off yet. I had taken a peek under the hood to see what it looks like. It doesn't look like this amplifier has ever been serviced, other than maybe some tubes put in and out of it. I'm pretty sure what I'm going to find under that. I'm just going to waste time undoing screws, but we'll make an exception. I'm assuming these are just self-tapping. Yeah. Pardon me. Oh, before I pull that, I wanted to show the mounting. If you're familiar with these or like them, that's the condition that they're in. This fastener's bent. This one's bent. These don't really support the full weight of the amp as it normally would sit. Well, they do, but even if these fail, the amp's not going to fall to the bottom. But nevertheless, I am not going to put this back into the this chassis back into the cabinet with these conditions. Well, if I'm instructed to, I will, but I would not recommend that. You can get fasteners. Rust on here. All right, so what's under here? Ugly. All original. There's a good thing and a bad thing about that. The thing is, I know nobody's been dorking around in here besides me. Yeah, you can see even inside of here, there's rust. Oh boy. And all kinds of, oh, where's my tapper? I need my tapper. Let's see what I'll see. Yeah, just tap with it anyway. Yeah. Dollars to donuts, every single one of these is completely shot. One of the most common troubles with these. Spin this around. What do we got here? Yeah, these are Mallory's. 70 microfarad, 350 volts. These two are connected in series, and I hate that. But that's what they did. It's tough on them. I think these are probably 20s. My memory serves. I was peeking at the schematic for the series a little while ago, just to refresh my memory some, such as it is. So there's no way this is going to operate with these in place. At least not in my house. Something odd about this reverb output jack. Not sure what that's about. Well, we'll get to that. So this line cord, it's the insulation is so bunged up. It's just very brittle. And right at the strain relief, right here, it has got to the point where there's only one thing. This will be the first modification I'm going to do on this amplifier. It's just and that. So there's no way anybody's plugging this amp in through that cord. Fiat face of fixing this. Well, let me check here. Yeah, it'll work. Flip her over. And check. I'm going to cut this here and refocus, and there's some couple of things I want to grab, a pad and a Sharpie back in a flash. Okay, oh, what do we got under here? Oh, well, some joy, some not. As you can see, there's rust. Quite a bit here. Not the end of the world, but that does indicate that this gal's seen some water over time. I notice I'm looking down in here. There's no pilot lamp installed, and I guess somebody needed it for something else. And the jewel, I'm screwing. I'm gonna need a tool to get that off. I hate to put tools on stuff like that, but we have ways. There's quite a bit of rust here on the leads from this power transformer. The leads themselves seem to be in fairly decent condition. They're cloth covered, flexible. Is about what I'd expect. I don't want to move this around too much, but there's all this mildew and rust particles all over it. There's like a blister here in the paint of this transformer. Some rust. So it looks like some water condensation maybe has found its way down into this some. Keep in mind that this face is when mounted in the cabinet. This is facing up. So any rain or condensation on, Lord, I'm looking at the top. Oh gosh. I'll talk about that later. See, right now I'm just kind of, my fingers brushing away mildew and some rust. I'm gonna have to, at some point I'm definitely gonna have to get some compressed air and blow this thing clear. Let's see, how many wires does this have there? Ooh, geez, what is that? That's a little crunchy. It's the heater wires for all of the tubes, except the rectifier, and that's. I don't know. Jeez. Oh boy. That's going to be a little dodgy. I have to be real careful about this. Some pretty high voltages in between these leads, not to mention the line coming in, these black ones, which are pinched right up against the opening for the wires. Good grief. There's so many things they did wrong, safety-wise, and that's one of them. These chassis are not grounded, and I'll point out a couple of things. Well, number one, I just did the line input leads. This is plugs into the mains, feeds through an opening in this shell, this end bell for this transformer, and they're right up against it. Well, this is in a thing that gets jostled around. It's in a thing that has vibrations because it's got speakers in it, and all it would take is for one of these to make a connection to this end bell, which is electrically connected to the chassis, which is electrically connected to whatever instrument's plugged into this thing. Oh, woe betide you. The other thing, this has the death capacitor in it. And I do mean that, death capacitor. You just look it up. And this, because there's no ground on this, they tie the chassis to one side of the line or the other, depending on how you toggle this switch. They connect the chassis through this molded paper capacitor down under here, directly to one side of the line or the other. If that cap shorts, you get live chassis, woe betide you. Maybe. People have been electrocuted because of that. If I do get this thing working, assuming no major issues with the iron, that's going away. Otherwise, I'm not working on it. I'm going to make sure I have the permission of the owner to do those things. But I'm not letting it leave here with a line cord on it with that in place. It's just not happening. This bothers me. This is why we ground things, so that should one of the other of these line mains inputs short the chassis, it blows the fuse. This line cord, I have every reason to believe that this, what's left of it anyway, is the original line cord. It may not be, but no way I can know for sure, but sure. given its state of affairs. I believe it is. And notice its proximity to the rectifier tube. For crying out loud, this wire is leaning directly up against what ends up being B+. So there's another opportunity for a mains connection, line cord, 125 volts to connect to, find its way to the chassis. There are other points. Nothing good mojo about that. Shame on you, Fender, for that. I know everybody loves these things, but I'll tell you, man, safety-wise, you suck. Big time for that. So, end of that rant. So, oh gosh, more to this. I don't see a whole lot of corrosion around these input phone jacks. Up around the controls, input phone jacks, they'll probably need to be cleaned, especially these pots. But I'm not seeing any excessive corrosion in chassis, on chassis in places up here, but not so much with these controls. We'll find out about those. They feel, most of them, okay, this one's real stiff. I don't want to mess with that yet. That's actually, it looks different. That might possibly be a replacement. I don't know. Yeah, we'll find out. These blue molded capacitors, it's touch and go. Those can be tested easily. Some of them, while in circuit, some of them have to lift them out, at least one of it, to check them. Odds are that most, if not all of them, are leaky. There are, I would suspect every single electrolytic under here, and all of them are just shot. This one here is actually a 2-section electrolytic. I don't know if you can see this, but the sleeve is split open. Yeah, so you peeled a piece of it away there, so clearly that's full bar. If I'm not mistaken, this socket is the one that looks burned, overheated, and this capacitor is associated with that circuit. So maybe the chain of events was this cat gave up the ghost, caused the overcurrent to put DC into the that small transformer that matches the tube to the reverb tank pan. That was at fault. Just one. Again, there's mildew, in places. These just caps, this feathery white stuff. These two capacitors here, I suspect those are not original. For one thing, they mark Japan. I think these two are replacements that some tech put in to replace one of these two-section caps. There's another one now. Where is it? I thought there were two. Yeah, there's another one up here. That one likewise is the case is split open, and whether that's the case, whether the case is split open or not, it's still there's. I bet my last penny that those capacitors are no good. These are likely suspect. This too. This I believe that's an original part in here. So I'm not going to go through and recap this just out of hand. Again, I'm going to have to await instructions from its owner. A great part of this video is just so he knows what it is here that he has. So, there's a board up under here, a small one, just like this. It's a fiber board. It's the bias supply for the output tubes, the grid bias supply for the output tubes. And it's got a big fat electrolytic on it. Low voltage, I'll say low voltage, 50 volts. And there is a solid state rectifier in there, single diode and a resistor. And that supplies the DC grid bias for the output tubes, negative somewhere between 30, 40 volts or so, depending. This amplifier has a bias adjustment control on it. This one, this vintage, this bias control is actually that. It controls the bias voltage to both tubes, and the level is the same for both tubes. Other models of this, permutations of this, rather than do that, the bias is fixed, but they wire this pot so that it acts as a bias balance control. There are caveats to doing it either way. With the way they've done it here, where it just adjusts the bias voltage and matching of the tubes be damned, well, if you have new tubes in it and they're very well matched, that's not too much of a problem. But you have no way to compensate for if one tube is a little bit more worn than the other. You've no way to compensate for that with this circuit the way it's wired. This could be converted back or to whichever way you like. But the way it's wired right now, this is just a gross bias voltage control for both output tubes. They both get the same DC grid bias, and therefore if one tube is stronger than the other, that tube will draw more current. It will clip unsymmetrically. Yeah, I'll get into the vagaries of that right now, but that's the deal. The folks, they talk about the black face. This seems to be wired like a black face, even though it's not a black face. There are clues to it. Number one, it's got biggest one, of course, is it's got a vacuum tube rectifier in it, not the solid state one that the most recent versions had. It does not have a balance control for the bias. It's just a simple controlling the bias for both tubes. The filament winding on this has a center tap going directly to chassis, where in some models it's a hum reduction thing. When I say filament, I mean heaters for the tubes. 6.3 volt heaters on all these tubes except the rectifier, which of course has its own separate heater filament winding. So in this one, the transformer actually has a center tap for the heater winding, grounded. Other models, I think earlier ones, you'd have to check me on this, they didn't have the center tap, but they just put a 100 ohm resistor between each side, each leg of the heater winding to ground, to 100 ohms each side directly to ground. It forms the same result. It may have been more or less expensive to have the manufacturer of the transformer add this center tap. Probably cost more to do. In fact, I'm sure it costs more to do that with this transformer. So maybe as a cost reduction, they did away with the center tap and just used the two dividing resistors, 100 ohm resistors, for that. Hey, by the by, anyone watching this, looking at this, has any complaints, criticisms, kudos, certainly suggestions, please comment. I'm not asking for subscribers, and don't bother clicking that up or down thumb thing. That's for pussy. So just go ahead and if you got something to say, please. Let's hear. I'll respond in kind. Preliminary checks. Well, first of all, I want to know. I'll go ahead and set DMM here just 3 ohms. Is the line in is the primary of this transformer open or shorted? 1.9 ohms. That doesn't read open. Well, I'll call it 1.8 ohms. But keep in mind that's DC, so AC 60 hertz. It's going to be quite different. Does the switch function? Yes, power switch functions. Open, closed. Okay. By the by, what is my meter lead? Call it 0.2 ohms. Alright, so I wouldn't complain about that so much. Let's see if there's any continuity between the chassis and either side of the prime. Well, just to be on the safe, I've checked both sides. There isn't. This capacitor would, if shorted, it would show here. As a matter of fact, this can check capacitance. Let's go for the blue button. What's that read? 24.2 nanofarad. Well, that's supposed to be, that's about right, 0.047. So it's showing that death cap down there, the death capacitor down there, which is at least something less than a few volts is reading. Okay, but that's going wait. So primary windings checks okay. Let's go back to ohms here. Okay. What's the heater winding measure? No, certainly not open. Now that's going to look like a dead short. The impedance of that winding is very, very low. I doubt very seriously if there's a dead short. It's possible, it happens, but if it has, we'll find out soon enough. And the center tap. Is that, no, the heater center tap. Yes, got continuity there. Okay, so the heater filament supply for the rectifier tube. Separate winding. 5 volts out. 3.2, geez, again, it's not open. Can't call it shorted because this meter with this range, in this low ohms range, it's not going to distinguish that. Okay, the high voltage winding, which is, not only is it center tapped, it has a side tap. So the 2 ends of the high voltage secondary are these 2 red ones, and they go right to the plates of the rectifier tube. That looks pretty good. 56, I'll call it 57 ohms. Now that's what it's quite a bit of voltage across that one. I'll put, what's it? Might have to look, but it's pretty high. It's a full wave rectifier circuit, so the voltage across these is twice what it is coming out of it. That's going to be probably about 600 volts, I think. And that has the center tap. Make sure that's not open. I wouldn't expect it to be. Well, look at both sides. That's got from the center tap of the high voltage winding to one end, it's 27.2 ohms. To the other end, 30, well, I'll call it 30 ohms. Fair enough. And slight discrepancies on those windings is insignificant. But then there's this other tap. That provides the bias voltage. See if I can get in here. The grid bias, since these are fixed bias, 3.9 ohms. That looks about right. So none of these windings are open. I don't think any of these are going to be found shorted to the primary or one another. That should read 30. That should read, yeah, close enough. That's the, let's see, we're going from ground to B plus. That's going to be the resistance right now of the filter string, those big honking electrolytics. 1 point something megohms right about now, but yeah, those things are probably dried out to complete open. They may as well not be there. So, okay, the power transformer. Continuity tests and at least low voltage interwinding short tests passed. Good. Well, move on. The output transformer. And that's the most important one in here. That's gone, well, not good at all. And this one's going to have, let's see, actually there's windings from another transformer coming in here. Oh, what is that? Oh no, that's the choke. Let's check that choke. 94 ohms. That seems a little high to me. That seems a bit high. But it ain't open. Given the amount of current that's drawn after that choke in the supply, that, yeah, sure, why not? That 100 ohms for that choke. Lots of turns of very fine wire. I wonder if they pay like 10 henries or something. Alright. The output transformer. That is what matches the output tube's plates to the voice coils. From one side to the other, I get 92.4 ohms. And there's a center tap. That's this one. Alright. Should be half. This should be the other half. And it is. Okay. So the primary winding of the output transformer is not at this voltage. It's neither shorted nor open. Good news. The output winding, it's single impedance output, single winding, 2 ohms impedance to the, that's the load it expects. That's when these things very rarely ever blow out the secondary windings, and it's the primaries to give up the ghost, and or a short between the primary and the secondary. Let's see, why would I see that? Okay. Think about this a second. The only thing, oh no, that's true. I'd have to isolate this center tap to truly get a leakage reading. Where I'm looking is between the output, the secondary of the output transformer, the speaker connection, one side of that to the one of the plate leads. One side of the primary, and the second side I'd expect to see much the same thing. But because the center tap of this winding is still attached, it can find its way, I do believe, a ground, yes. These outputs are ground referenced for the feedback mechanism, so that makes sense. Well, megohms doesn't, because that if those electrolytics were working, that would be quite a bit different. But there's no direct short. we'll test for that once I actually get some bolts flowing through the thing. The plan is just kind of sneak through this, and a little bit at a time. From what I'm seeing so far, the iron's good. I almost forgot. Got one more transformer to look at. This one has to do with the reverb tank circuit. Where is he? It's up here. Yeah, here we go. 4 leads for that. This will be the secondary. Would expect no trouble with that. 1.2 ohms. That looks about right. It's not dead short and it's not open. And the primary is going to be from this over to the plate of this 1287. Oh man. That Houston, please no. Yeah, that's meg ohms. That's going through the circuit. This, oh crap, that sucks. Well, guys, it appears that the matching transformer for the reverb tank is open circuit on its primary. That sucks. Doesn't mean the amp can't work again, but without replacing or substituting that transformer, there's going to be no reverb. I kind of predicted that, I showed the damage to the socket. There was some serious heat there. As a matter of fact, I've got 2 here. There was one that really looked like it took a big hit. What's this guy? This one. Yep. 12AT7. That tube is burned. The gutter's completely wasted. Not because it got air in it, but because of outgassing. It overheated. And cathode stains all over it. This is number 7. Let's see, that would have been 1, 2, 3, 4, 5, 6, 7. Yep, that's the tube in that socket. This tube is complete Zorch. And so is the transformer for it. That sucks. I'll double check here and make sure. Nah. Wire's not busted. Now that I'm looking at this closely, I think that's been touched by a tech. And even up here, there's something fishy about that. It's actually a twin triode, two separate triodes in this tube. And they wire both of them in parallel in this circuit to get the power needed to drive that reverb tank's input, which is kind of like a speaker, except it drives a spring and not a voice coil, a cone, a speaker cone. And I call it this way: capacitor failed, excessive current through the tube, opened the transformer. It may have shorted for, I don't know. But odds are the chain of events, the root cause of that failure was this electrolytic capacitor. And it cascaded. So, yeah, bye-bye reverb matching transformer. Sometimes those can be fixed, but I don't know if we have time and money for that. There probably are replacements available. for that part or component. If not a direct replacement, a substitute, there are people out there that know what that needs to be. Input and output, impedances and matching and deceivers and all that. But for now, that one's not happening. Fortunately, this amplifier can work in spite of that. It just won't have reverb. And I haven't even looked at the tank yet, the pan. It may be foobar as well. I don't know. At this point, I'm not terribly worried about that. So, that's a sad discovery. I'm going to apply some power to this and take some measurements. No tubes in, no high voltage elsewhere other than what's, double checking some more about this power transformer, and particularly this bias circuit. Oh boy. So we'll cut this here and make this, I guess, number 2 of how many? Don't know yet. See it.